I mention that now because we have this 35 degrees given. So you see 35 degrees showing up in the answers, but then you also see this 55 degrees. Is that completely random? Of course not. If we've got 35 degrees right here, how would I find out what this angle is going to be? That's right, I'm going to go 90 minus the 35. Guess what that turns out to be? 55. That's where this 55 degrees is coming from. That's why it's there. Okay, so keep that in mind. Now, on to the heart of our story. Let's put some variables so we can keep track of these sides. Let's call this side length x. Okay, this is x inches long, or whatever. I'm going to call this side y. Alright, that's the length of this side. And I'm going to call this h for hypotenuse. Now, the tangent of 35 degrees, that's our original problem. Let's think about what the tangent of 35 degrees would be using the variables that we have. First of all, remember the definition of tangent. Opposite leg over adjacent leg. So if I stare at the 35 degrees, the opposite leg is the opposite leg is y, because that's far. The adjacent leg is x, because that's near. So opposite over adjacent, the tangent of 35 in this picture would be y over x. Now, if I have 1 over the tangent of 35 degrees, for example, all right, 1 over a fraction. Say if I had 1 over a over b. When you put 1 over something, that's just the reciprocal. 1 over a over b is the same thing as b over a. Let's test that theory. Okay? According to what I just said, if I do 1 over 3/4, what should I get? I should get 4 over 3. Let's test that out. Okay, let's see, 1 over, alright, I really want that in parentheses if I can. Okay, 1 over 3/4. Okay, let's see what I get. Boom, 4 over 3. Okay, so if I do 1 over any fraction, all that does is cause the reciprocal, 4 over 3 in this case. Okay, so 1 over a over b will give me b over a. Keep that in mind. Okay, so if I do, I'm looking at option B for a second. If I do 1 over tangent 35 degrees, all right, tangent 35 degrees is x over y. So that's like having 1 over y over x. Did I say x over y? Tangent 35 is y over x. So 1 over tangent 35 is like having 1 over y over x. What would that be? Well, that would be x over y. Obviously, that's not the same thing. Okay? Now, compare that to option D, which we decided was the right answer. Okay, looking at option D, 1 over tangent of 55. Okay? Let me change color. So 1 over tangent of 55. Well, let's start by knowing what tangent of 55 is. All right, tangent of 55, again, tangent is opposite over adjacent. So staring at the 55, the x would be opposite, and the y is adjacent. Okay, far, near. So tangent of 55 in this triangle would be x over y. Okay, so 1 over tangent 55 would be like having 1 over x over y. Now, what does it do when I put 1 over a fraction like this? It just causes the reciprocal. So that would just be 1 over y over x. Now, these are the same, y over x and y over x. That's why the tangent of 35 is the same thing as the tangent of 55. The tangent of 35 is the same thing as 1 over the tangent of 55. Okay, that's why D was the answer. Okay, I know that was a lot of information, but this is that next level. I'm trying to get you to think on a higher level. Let's do it one more problem like this. Look at problem number 8. Which expression is equivalent to cosine 63? Again, I could just type all these into my calculator and find the right answer very quickly. And you know what? If you're taking the some standardized test, that's probably exactly what you're going to do. But as a teacher, I want to get you to think on a higher level. I want to exercise that brain of yours. So go on this brief journey with me. It will not hurt you. You might even feel better about yourself. What expression is equivalent to cosine 63? So we have 63 degrees. Let's imagine that this is 63 degrees. Now, do you remember what I just taught you? What is the quickest way to know what this angle over here is going to be? Yeah, let's just do 90 minus 63. That's going to give us this angle. That turns out to be what? Turns out to be 27 degrees. Okay, that's where this 27 is coming from in these answers, by the way. Okay, so fine, 27 degrees. What of it? Now, cosine of 63. Let's build an expression. Let's go back to this. X, y, and h. If I want to talk about the cosine of 63, okay, cosine of 63, what is the definition of cosine? Adjacent leg over hypotenuse. Okay, looking at the 63, then this is my adjacent leg, and that is, of course, the hypotenuse. So that's going to be y over h. Okay, so cosine of 63 is y over h. Now, let's look at the sine of 63. Okay, the sine of 63, what's the definition of sine? Sine is opposite over hypotenuse. Okay, so if I want to talk about the sine of 63, all right, which is answer A, the sine would be opposite over hypotenuse. That would be x over h. Y over h, x over h. That's two different things. So that's why A is not the answer. Look at B, sine of 27. All right, if I look at the sine of 27 degrees, now I'm looking at the other angle. So sine, again, is opposite over hypotenuse. So from the perspective of the 27, this is opposite, and this, of course, is the hypotenuse. So sine of 27 would be y over h. Y over h, y over h. So cosine of 63 is going to be the same thing as the sine of 27. Okay, that's why B is the answer. But look, let's go ahead and generalize that. this same pattern is going to happen no matter what these angles are. Okay? In other words, let's see, let's make these be something else. Say if I had the cosine, say if I had the cosine of, I'm just making something up, 71. Okay, then that makes this a 71. Guess what this is going to be over here? This is going to be 19. 71 and 19. Guess what? Cosine of 71 is going to be the same thing as the sine of 19. Alright, this is going to happen every single time. If I said, if I talked about the sine of, let's say, 46, okay, so let's say this is 46 up here, then what's this going to be down here? Alright, that's going to be 44. So guess what? The sine of 46 is going to be the same thing as the cosine of 44. So this is a general pattern that we're going to run into over and over again. So it is worth being familiar with.